Good day everyone, welcome to our physics series. Today we will be discussing quantities, units and dimensions. Physical quantity. A physical quantity is a property of a body or substance that can be measured and expressed using a numerical value and a unit. Examples are length, mass, time, electric current, temperature and amount of substance. Physical quantities are broadly classified into two types: fundamental quantities and derived quantities. Fundamental quantities are basic physical quantities that cannot be expressed in terms of other quantities. They form the foundation from which all other physical quantities are derived. Examples are length, mass, time, electric current, temperature and amount of substance. Now next we have derived quantity. Now these are quantities that are obtained from a simple combination of fundamental quantities. Example are area, volume, force, speed, density, etc. Now the next concept we'll be discussing is unit. A unit is the yardstick with which a quantity is being measured. That is, quantities are measured in terms of units. For example, the units of measurement of length are millimeter, centimeter, meter, kilometer, etc. Length could also be measured in inches, feet, yards, miles, etc. The units of measurement of mass are gram, kilogram, ton, etc. And the units of measurement of time are second, minute and hours. Like fundamental quantities, we also have fundamental units. Now fundamental units are basic units that are not dependent on other units. In other words, they are the units of fundamental quantities. Examples are meter, kilogram and second. Now the table below gives the fundamental quantities and their units. Now the first quantity we have is length and the unit is meter. The next is mass and the unit is kilogram. We have time, the unit is second. Electric current, the unit is ampere. Temperature, the unit is Kelvin. Amount of substance, the unit is mole. And luminous intensity, and the unit is candela. If you can observe properly, the units given here are SI unit, which we will be discussing later on. Derived units. Now these are units that are obtained from a single combination of fundamental units. That is, they are derived from and dependent on fundamental units. Simply put, they are units of derived quantities. Examples are area, volume, force, speed, density, etc. Now we'll be looking at how derived units are derived from fundamental units. Now derivation of derived units. It is very important to know how derived units are obtained. Below are the steps followed in deriving units. Now our step 1 is to write down the defining equation. After doing that, we are going to expand the expression in terms of the fundamental quantities that makes up the derived quantity. That's our step 2. The next step, which is step 3, will be to state separately the units of all the fundamental quantities. Our step 4 is to combine the units as the quantities are combined in the expanded expression. 5 is to reduce the expression to its lowest form, and 6 is to write the resulting expression in the index form. That is the way we usually derive our derived units from fundamental units. Below is some derived quantities and their SI units. Now the very first quantity we have is area. The defining equation for area is length times breadth, and the derived unit is meter square. The number 2 or the second one we have here is volume. The defining equation is length times breadth times height, and the derived unit is meter cube. The next is density, which is mass over volume, and the derived unit is kilogram per meter cube. The next quantity we have is velocity, which is displacement over time, and the derived unit is meter per second. The next unit we have is, or the next quantity we have is acceleration. The defining equation is change in velocity over time, and the derived unit is meter per second square. We have force, which is mass times acceleration, and the derived unit is kilogram meter per second square. We have energy or work, which is force times distance, and the derived unit is Newton meter, which is also called joule. Now we have power, which is work over time, and the derived unit is joule per second or watt. We have momentum, which is mass times velocity, and the derived unit is kilogram meter per second. We have pressure, which is force over area, and the derived unit is newton meter per second square or pascal. We have some example we should be attempting. Now our goal is to try and derive the unit or some derived quantity. Now our very first example 1 says that derive the unit of density. Now using our step in the previous discussion as guideline, our step 1 is to write down the defining equation. Now in this case, density is mass over volume. Now the next step is to split it out in terms of each fundamental quantity it is made up of. Now mass is mass, while volume is length times length times length. So it becomes mass divided by length times length times length. Step 3 is to write down the unit of each of the individual fundamental quantity. We know that mass is kilogram and the unit of length is meter. Now substituting these units into step 2, our step 4 becomes unit of density will be equal to kilogram divided by meter times meter times meter. Since there is nothing that is going to cancel out, our step 5 in this case is not applicable, so we cannot break it further or simplify further. So our step 6, unit of density will be equal to kilogram divided by meter cube or kilogram meter raised to the power of minus 3. Now for our very next example, we are asked to derive the unit of force. Now for our solution, our first step or our step 1 is to write down the defining equation, and we know that force is equal to mass times acceleration. For our step 2, it becomes force will be equal to mass times in bracket length divided by time times time. That's we are broken acceleration down. We should make force to be equal to mass times length divided by time times time. Now for step 3, we know that the unit of mass is kilogram, the unit of length is meter, and the unit of time is second. So substituting the unit for the quantity in step 2, step 4 becomes unit of force will be equal to kilogram times meter divided by second times second. Since we cannot break this down further, step 5 is not applicable. So for our step 6, unit of force will be equal to kilogram meter divided by second square, which can also be written as kgm s to the power of minus 2. System international in bracket SI units. Now these are units that are internationally accepted by scientists as standard units of measurement. Every quantity has more than one unit of measurement. For each quantity, there are smaller units and there are bigger units. However, for uniformity, the international system of measurement called System International in bracket SI generally accepted and agreed on some units as standard units of measurement. These units are called SI units. For example, the 7 SI units for fundamental quantities are the meter for length, kilogram for mass, second for time, ampere for electric current, kelvin for temperature, mole for amount of substance, and candela for luminous intensity. Now the last concept we'll be discussing is dimension. Now the dimensions of a physical quantity show how it is made up in terms of the basic quantities. Dimensions are measurable properties used to describe the physical state of a body or system. Just as we have fundamental and derived units, we also have fundamental and derived dimension. Dimensions can be derived following the steps given for the derivation of units. For step 3 to 4, simply use dimensions in place of units. Now we have some examples to explain how we derive dimension. Now the very first example states that derive the dimension of power. That's our example 1. Now for the solution, for our first step, defining power will be equals to work over time, which is also equals to force times velocity. We know that velocity is length over time, that's meter per second. So for force, we are going to be breaking down bit by bit. So for our step 2, power will be equals to force times length over time. We know that force is equals to mass times acceleration. So force will be equals to mass times meter divided by time times time, that's meter per second. So force will be equals to mass times meter divided by time times time. We should make power to be equals to mass times meter divided by time times length divided by time, and multiplying it becomes power is equals to mass times meter times length divided by time times time times time. Now for our step 3, dimension of mass is m, dimension of length is l, and dimension of time is t. Basically, dimension is basically the abbreviation of the quantity itself. So for mass, the dimension, which is the abbreviation, will be m. For length, the dimension, which is the abbreviation, is l. And for t, the dimension, or for time, the dimension, which is the abbreviation, is c. Because in dimension, we are basically representing the derived quantity in terms of their basic fundamental quantity, not the unit, the quantity itself. So we are using the abbreviation of those quantity. So for our step 4, dimension of power becomes m times l divided by t times t times t. That's, we have now substituted the quantities with their abbreviation or their dimension. So our final step, the dimension of power will be equals to ml squared divided by t raised to the power of minus 3. That's multiplying everything in step 4. For our example 2, we are told to derive the dimension of density. Following our steps, step 1 is basically to define the quantity itself, and density is equals to mass over volume, which we make in step 2. It will become mass divided by length times length times length, because volume is meter cube, which is also length cube. Now for our step 3, you know that the dimension of mass, that's the abbreviation for mass, is am, and the dimension of length, the abbreviation for length, is l. So substituting m and l into step 2, the dimension of density becomes m divided by l times l, and since we cannot simplify it further, our step 5 and our final step, dimension of density will be equals to m divided by l cube. Here are some exercises for you to revise this chapter on. Now for more insight on this topic, you can check out our Hidden Fact Physics textbook. You can get the hard copy in bookshops, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.